Alright, to review for the final, we're going to go back over very briefly and quickly all of the units we've done so far. So this was the very first not nature of science unit we did, and it was on the properties of matter. So there are two different types of properties of matter. You have properties that are always the same no matter how much of that object you have, or you have properties that can change depending on the amount. Properties that are always the same no matter how much you have, some examples of that's density, which is the ratio of mass to the volume, thermal conductivity, which is how well it conducts heat, electrical conductivity, how well it conducts electricity, solubility, does it dissolve in water, magnetism, is it magnetic? If you put a magnet near it, does it line up magnetically? The melting and boiling point, that's the temperatures at which it changes states, and flammability, does it catch on fire? Those were all, again, properties that are always the same no matter how much of that object you have. Then, like I said, there are properties that change depending on the amount. Those examples are mass, which we'll go over, weight, we'll also go over, and volume. Still going to go over that one. So I said we'd go over them, we're going over them. The first one's mass, which is the amount of matter in an object. And the second one is weight, which is the measure of gravity on the object. Now these are two that people get confused really easily. So I want to give you the most simple definitions and give you an example. Mass is how much matter there is, how much of that object there is. For example, your mass is how much of you there is. Your weight is how much gravity is pulling down on you, okay? Or how much gravity is pulling down on that mass, whatever that mass is. So for example, you might have the same person on a spring scale, so this is gravity pulling it down, a spring scale on the moon, and it might come up that they weigh 10 pounds. They're this size. There's that much of them. On Earth, same amount of the person, but now that spring scale pulls down farther because there's more gravity, so now they might weigh 60 pounds. Again, it's the amount of matter, the amount of mass did not change. There's the same amount of person, but the amount of gravity, the amount of force pulling them down, pulling that spring down, did change. Then you've got your volume, which is how much space an object takes up. So that volume is how much space it is. How much is it taking up? If you put it in water, how much water does it move? That one's called water displacement. If you have it in a room, like if you're trying to pack a moving truck, it doesn't matter how much mass or how much weight that object has. It matters how big it is, how much you can cram in there. Okay? Now if you take the mass and the volume and you put them in a ratio, you get density. As a reminder, mass is how much of something there is, and volume is how much space it takes up. So here's examples of objects that take up the same amount of space, but they have a different volume. This is a bowling ball. It has much more mass than this balloon, which has much less mass. Same amount of space, same volume. They would have different densities because there's a much different amount of mass in each of those objects. We'll briefly go over density. Density is one of those things that you may have to calculate. The formula for density is mass divided by volume. From this formula, you can calculate the mass, which would be density times volume, or the volume, which is density divided by mass. Density can also tell us whether or not an object sinks or floats. And then you're comparing it to whatever you're putting it in. Most likely, that'll be water. And water has a density of 1 gram per milliliter. That's the mass divided by volume. If an object floats, it has a density less than 1, a density where it can be on top of it. If it sinks, it has a density of more than 1. So we were talking about these physical properties. We're talking about these properties of matters. There are two types of properties. You can have a physical property or a chemical property. They seem a lot alike, but there's a key distinct difference. When you're observing a physical property, you can observe it without changing the identity of a substance. For example, if you're going to observe the weight of something, weight's a physical property, you just put it on a scale. If I take a piece of paper and I want to know how much it weighs, I put it on a scale, I find out how much it weighs, it's still a piece of paper. Nothing's been changed about it. With a chemical property, it can only be observed by changing the identity of the substance. For example, flammability. If I want to see if that piece of paper is flammable, I have to light it on fire. Then, what I've done is I've changed part of that paper to ashes. I've changed the identity of that substance. It's not paper anymore, now it's ashes.